Hi everyone, welcome back to the part 5 of our Python problem solving series. Today we are going to be focusing on medium level array problems. Those of you who have not watched our easy array problem solving video, I will link it somewhere here so you can go and check that out too. So that's all. Let's jump right in. Hi guys, today's first problem is two-sum problem. So given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. Okay, you may assume that each input would have exactly one solution. Yes, that's what I was going to ask. You may not use the same element twice. Correct. Okay, that makes sense. You can return the answer in any order. Okay, fine. What I'll do, okay, what I can do further is, let's say, so let's say the way I'm thinking about this is, let's say we have an array, we have 2, we have 2, we have 7, we have 11 and 15, and target is 9. If that is the case, then first I will take a dictionary here, dictionary or hash map basically. So I will save 2 and its index, similarly 7 and its index, and at each turn of the element checking in array, since I'm trying to do this only one traverse of the loop itself, I will subtract the earlier I will subtract 9 minus, or the target minus the element in the array, and try to check if that particular element, if it exists within dictionary somewhere or not. If it does, then we will just return the index of this particular element as well as index of the earlier particular element, and that's it. We're done. Since it is two-sum problem and it is particularly told that there will be only one instance of two elements whose addition will be the target value, so we do not have to traverse the whole array in this case. We can just stop anytime we are getting the final, or any combination that is bringing us to the target value. Okay, so let's just do this. I will, let's say, initiate one particular hash map or dictionary in Python for I in range of length of nums. And what will I do? I will take if, let's say, target minus nums of I in diction.keys. If that is the case, target minus nums of I in diction.keys, then we will return, right? Because it already exists. So we will return the index of the ticked off target minus nums of I, comma, I, right? That's what it is. Because let's say 2. If 2 is there, there is like target minus 2, that is 7, is not already existing in dictionary. It will be added at the second step. So at the second step, let's say 9 minus 7, 2. 2 is already existing within the dictionary. If that is the case, then we will return the index value of the other element first, and then the index value of the current element. That's what we are doing. And let's say if it is not existing, nums I not in diction.keys, then we will just add that. So diction of nums of I would become I, right? Because we are adding the index. And then at the end, we will, we are not returning anything basically. After this is done, if no other value is there, we can return a list. We can return a list here. That's it. Let's try to run this. Is the valid value for expected return type integer? Okay, let's not do this. Let's check. Dict 2, 1 is not a valid value for the expected return type of integer. This is not integer, list of int, right? Not dict, section. Oh, ho, ho, ho. This is not correct. Sorry. Run. Closing parentheses does not match the opening parentheses. Yep. Okay. Cool. Yeah. So we're done. And I think this is pretty easy one. Since it's only two sum and only one instances of the elements can actually stay within the array. So I think we can have many other variants of this particular problem later on. We will figure that when we get to that. Okay, so let's move on to the next problem.
So just to give you guys a little bit of context, if you guys are interviewing for product companies, the first 1 or 2 rounds will be based on your coding skills. So they will test you on your technical capabilities, and being proficient in SQL is already non-negotiable. And on top of that, you'll be given choice of any of the language to solve basic to medium level DSA problems. Now, I have chosen Python here because I know that many of us are already good with Python. So rather than learning another language like, let's say, C++ or Java, we can just go ahead and think about solving the problems rather than learning another language. But it's completely up to you to solve these problems in any of the language, because at the end, what matters is if we are able to understand and solve the problem in proper time and space or not. So, all right, I hope that helps.
Okay, so the next problem is sort colors. Given an array nums with n objects color red, white and blue, sort them in place so that the objects of the same color are adjacent, with the colors in the order red, white and blue. We will use the integer 0, 1, 2 respectively to represent the same. Got it. Okay, so you must solve this problem without using the library sort function. So do not return anything, modify nums in place. Okay, got it. So this will be there will be an array containing 0, 1 and 2, and that's it, and we'll have to sort that. That's it. That's the problem. Now we will solve this problem using a different algorithm. It's known as Dutch national flag algorithm, and I'll walk you through that algorithm in some time. But just to give you the context, why will we take a separate or different algorithm for this particular problem solving is because we could have, let's say, solved this particular problem using some extra space, or maybe using O of n square time complexity, using normal sorting, bubble sort maybe, but that is not what is intended. We have to do it in place. So even in quicksort, we can either do, let's say, in place quicksort, but majorly in quicksort we have to do recursion calls. In this particular function is not created that way, and let's say you can create a separate function and do that, but that will be much of an hassle. So I think it's better that if we can solve this in O of n time complexity, on top of that we will learn a new algorithm as well. So that's better. So let's just move ahead. I'll show you how and what is the Dutch national flag algorithm altogether. Right? Okay. So let's say we have an array 2, 0, 2, 1, 1, 0. Okay. So this is the array that we have. See, this is the array that we have. So this is what we are trying to replicate. Now, what is the Dutch national flag algorithm? There we will take, see, 3 pointers: low, mid, and high. Right? So we can take, let's say, low here, let's say mid also here, and then we can take high here. Why? Because let's say low and mid basically are quantifying or indicating the first element of the array, and then high is basically indicating the last element of the array. Why that is the case, these two are basically the indices. Now low and mid can start from 0 index, and high can start from length -1, right? Length of the array is 6 minus 1, 5. So high will be 5 in this particular case, and low and mid will be 0. And then the algorithm goes like this. Let's say if your mid is equals to 0, then mid is 0, right? So we will go ahead and we will increase mid by 1. Okay, so mid will move here. If it is 0, then mid will move to the next place. So let's say if mid equals to 0, so mid will be the main pointer. Mid will somehow work as the pivot point for us. Okay, so mid will be the main pointer. So if mid equals to 0, then what will happen? We definitely want to make sure that 0 comes towards the left side of the array, right? So what is low, mid and high? Basically mid is something which should be there in the middle of the array, high should be at the end point and low should be at the starting point. Now mid also is something that we have started from 0, so we want to make sure that mid goes till the middle of the array and then high somehow comes towards here, sorting the right portion of the array, while low and mid together helps us to sort the left portion of the array, right? So, and all of this will happen using mid as the main iterable throughout the loop altogether, right? And what will we do? We will see if mid is 0. So basically we will make sure that 0 will come towards the left portion. So we will swap mid with low and then we will increase their pointers, increase their values, right, by 1. Then if mid is 1, we won't do anything. So 1 is necessarily in the correct place. 1 should be in the middle. So we will just increase the middle value as pointer, mid pointer by 1. And then let's say when mid equals to 2, that means that should go towards the right? So we will swap with high position and then we will decrease high from their last position towards last but 1 position and so on and so forth, right? So that we know that absolutely we are sending all the. So that's it. That's how the right portion of the array also will get sorted, and as well as the left portion also will get sorted, while the middle section staying the same with 1 as the values there. Okay, hope the understanding is clear. Now I think it will become clearer when we code and when we run the program. So let's go back here. Okay, so I have taken low, mid and high equals to 0, 0 and length of nums minus 1, and then based on the logic that we just told, there we want to make sure that mid is always lesser than high while the loop is running, and once mid is greater than high, then we can safely say that your array is sorted and we can get back. So if, let's say, if mid equals to 0, then what will we do? We'll just do nums of mid comma nums of low equals to nums of low comma nums of mid. So we'll just swap both of the positions and then we will increase mid plus equals to 1 and low plus equals to 1. And if say mid equals to 1, right? So nums of, no, actually if mid equals to 1, then that's great, right? So it's in the correct position. So we won't do anything, and else if mid equals to 2, that's the only option that's left. So what will we do? We will just exchange the position of mid with high, and that's it. We will decrease this particular array pointer by 1. Okay. And then we will just return, since we do not have to do anything, we'll just return null. That's it. Let's run. Okay. 201102. Okay. Ideally, this should work just fine. Nums of mid, low, low, and mid. Okay. Mid plus equals to 1, low plus equals to 1. Oh, not mid equals to 0. Mid will always be 0. This is nums of mid equals to 0. Else this. Yep, let's run. Okay, let's submit. So again, I would ask, yeah, this is perfectly solving the particular question. I would ask you guys to practice the Dutch national flag algorithm altogether, how it is happening, how taking 3 pointers at one go, starting 2 from one end and starting another one from either of the other side of the array. It's actually helping us to sort the whole array at one traverse itself. We are not having to traverse the array multiple times. This will definitely help. This is a very good concept, and how multiple pointers can actually help us solve the problem in lesser time complexity, right? Okay, so this one's done. Let's move on to the next question.
Before jumping in, I would like to request you guys to please subscribe to our channel and consider liking our videos if you are benefiting from the content, because it will just help increase the reach of such videos to people in need, similar people who are also preparing for job interviews.
Okay, so the question is majority element. Given an array nums of size n, return the majority element. The majority element is the element that appears more than n by 2 times. You may assume that the majority element always exists in the array. Oh, okay. I will just take a dictionary and then count the values of each of the elements, right? Yeah, that's what I will do. Range of length of nums. So I have taken a dictionary here where I will be taking all the elements of nums, which is let's say 3. 3 is appearing twice, one here and one here, and 2 will be appearing once. So my dictionary will look something like 3 is to 1, comma 2 is to, 3 is to 2, comma 2 is to 1, right? So let's do that. If, let's say if nums of I not in diction.keys, then we will add diction.nums of I equals to 1. Else, if it is there, then diction of nums of I plus equals to 1, right? Because we will just increase the value by 1. That's it. We have the dictionary ready. And now we'll have to figure out which of the keys. So for I in range, yeah, we can take another loop. That's fine. Since we are not nesting it, it's still within O of n. So for I in range, dict.items, not items. No, not range. Let's say for I in dict.keys. Oh, or let's do that. For k comma v, key value pair in dict.items. If that is the case, key value pair basically. So return, we'll have to return the key for k in, sorry, return k for v in dict dot values. Or we don't even need this. Okay, I can just do direct list comprehension here. So return k comma v, k for k comma v in dict dot items if dict dot values would be length of nums by 2 greater than length of nums by 2. So yeah, let's see. Expected indented block. Oh yeah, of course. Let's run invalid syntax. Return k okay. Let's do something like this. For k comma v in dict dot items, if dict dot values greater than length of nums by 2, or just v. If v is greater than length of nums by 2, return k. How about this? Unbounded method items need an argument. Oh, not dict. This will be diction. Okay, right. Yep, this is accepted. Cool. So hope this is clear. We're just creating a dictionary. So basically we are taking constant space, but we are solving this in overfine. So we should go. Now, let's move on to the next question. Kadane's algorithm. Maximum subarray. Given an integer array nums, find the subarray with the largest sum and return its sum. And subarray is all the adjacent numbers, not one here and then one here. No, we have to have adjacent numbers. That is being called a subarray. Nums equals to 1, then subarray 1 has the largest sum 1. Nums is this, then 23 has the largest sum 23. So we definitely, since this is a summing problem, so we'll have to take a separate variable which will be keeping the sum. Yes, absolutely. I think that. Largest sum. So let's say this will be my final sum. I can say sum final, not count sum. Let's say I can give sum final, and sum would be something like a cumulative sum or an intermediary variable which will help me find out the final sum. So both of these are initiated to 0 for I in range of length of nums, and then keep on adding if sum final would be the final one. If sum or sum final is less than sum equals to sum, let's take a sum temp because sum is a function, so it will throw an error in some time. So if I take the variable name also as sum, okay. So if sum final less than equals to sum temp, which is correct, we just keep on adding sum temp, right? So let's go ahead here. Sum temp would be plus equals to nums of I. That's for sure. It'll keep on increasing. If sum final less than equals to sum temp. Okay, so let's print this, okay? So print sum final at each step. And let's print sum temp as well. Print sum temp. Okay. Let's run and check what's happening at each of the step and why is this coming out. So first it's -2 and sum of final is also -2. -1, -1, yes. 4, 4. -2, yes. -1, yes. -1 plus -3, that's -4. And not 4, right? Okay, let's see. Sum of final less than equals to sum. Okay. Sum temp plus nums of I, that's -3. So sum temp becomes -1 minus 3, that's -4. So sum of final, which is -1, is less than equals to sum of temp? No, not the case. Sum temp becoming 0. Fine. Then again the next one, 0 plus 4, yes. Sum of final less than equals to, it's -1, less than sum temp, yes. Sum of final equals to sum temp, 4. 4, 4, okay. Again going here, 4 minus 1, that's 3. Sum of final less than equals to sum temp? No. Coming 0. Coming here. Sum temp plus nums of I. So that's -1, sorry, 2. Oh, okay. Got it. Because 4 is the highest one. After that, everything is, if there is one negative at least, then the sum is becoming negative, or sum is becoming lesser than what it was previously. I think it makes more sense if, let's say, sum of temp becomes less than 0. Right? So if it is less than 0 only, then it becomes 0, right? Because anything which is negative and adding that with a positive number only lessens it down. So better start from the positive number altogether, right? That's what this particular piece of the code does. And yeah, that's all. We will check everything else remains the same. Let's run this code. Yep, this is accepted. So let's submit. And this is accepted there as well. So what's happening? So basically this is -2 and this is -1. So every time this is, let's say, -2, sum of temp is actually less than 0. This is 0, 0. Then again this is -1, then this is becoming 0. Then this is, but if you take a look at the code, right? So let's say, what if all the elements in the array itself is negative? So if I add one negative number with another negative number, this is bound to be this is about to be highly negative compared to the first one, right? So that's why what we are doing, we are first at the end, at the starting itself, we are just adding the nums of I with sum of temp, and then we are replacing, if sum of final is less than equals to sum of temp, we are replacing that. So in this way, at the first starting piece of the code itself, we are replacing the sum of final with the the least negative number possible. So if it's -2, then sum final will be -2. But let's say if we have one, let's say just one as an element within the array, we want to make sure that sum -2 is getting replaced by 1. And that's it. That's all we are doing here. If this is becoming negative, we are just reinitiating sum of temp to be 0, so that we are starting afresh. Right? So hope that is clear. This is known as Kadane's algorithm. This is this particular algorithm that we just solved. Basically, whenever this is negative, just make it into 0. That's Kadane's algorithm. Okay, so let's move on to the next question then. Okay, so let's move to the next question, which is maximum score from subarray minimums. Okay, given an array R with zero-based indexing, select any two indexes I and j such that I is less than j. Okay, from the subarray I to j, select the smallest and second smallest numbers, add them, and you will get the score for that subarray. Okay. Return the maximum possible scores across all the subarrays array and R. Got it. Okay, let me explain. I think only then it'll be helpful. Let's go ahead, clean this up. Okay, so let's take this particular array. Let's take this array and let's take this here. Okay. Again, pardon my drawing skills, I'm still learning. But anyway, so this is the array that you have. So what is a subarray? Subarray, and that too they have given I and j. That means your subarray needs to have minimum of 2 elements. So let's start from there here. 4, 3. So 4 and 3, the smallest and second smallest is 3 and 4 here. So your score of this particular subarray is 7, right? And then let's say if you increase this to include 3 elements, so 4 plus 3 plus 1 score is 4 plus 3 plus 1 is the subarray, and then your minimum score is 4, or score for that subarray is 4. If you increase this, then again 4. If you again increase this, this is 4. This is 4. Then let's say, fine. So let go of this particular section of subarray. And if I draw again So let's say all my subarrays containing number 4 is done, and the maximum score that came there was 7. Now let's start from 3. So let go of 4 altogether because 4 has been included in all the possible subarrays. Now starting from 3, 3 and 1. That's 4. 3, 1, 5 again 4. 3, 1, 5, 6 again 4. That's the minimum possible score with the smallest and the second smallest element within that particular subarray. So 4 is definitely not greater than 7. So 7 is staying intact. Now let's start from 1, 5, 6 or start from 1 basically. So the first subarray that can be there is 1 and 5. So the summation is 6, which is still less than 7. So 7 is not getting updated. Then 1, 5, 6, again, smallest and second smallest summation is 6, which is not greater than 7. We are letting it go. Then starting from 5, 5 and 6. 5, 6 is 11. Is it greater than 7? Yes, it is. It is actually greater than 7. So that's why my output would be 11, which is basically nothing but consider all possible subarrays, and within every subarray, take the summation of smallest and second smallest number, add them, and whatever is the maximum score that you can get from that particular subarray, smallest and second smallest element is your final output. Hope that is clear, and let's now break down the approach that we are going to take for this. Now, if I start with Bootstrap, then what will I do? I will take maybe this particular starting element, then I'll take these 2, these 3, 4, 5, etc. Again, I will start from here, take this, all the ones. Again, start from here, take these, and then start from here, take this one particularly. Okay, so I would say for this particular problem, start with the approach that you have in your mind, and then you can go ahead, start optimizing it. So let me take one particular variable, which is 0, which is basically the sum that I'll return at the end of the function call. So first of all, let's take for I in range, let's say length of R, right? And then I is starting from 0. And for j in range of I plus 1, right? We have to. And length of R. That's it. That's all you need to do. Now what will I do? I have taken this 4 and then I have taken j from here. So I keep on increasing. So let's take count sum. If count sum, or not if, let's take count sum equals to max of count sum, comma, it will be sum of the array. Okay, so here what will we have to do? We have to take sum of sorted array, right? And we have to take smallest and second smallest element, right? So sum of sorted, then R of starting from I till j, not j plus j. Yeah, j is I plus 1. So that's fine. I equals to I to I plus 1. No, actually, we'll have to take one more because there are 2 elements. At least we need to take 2 elements, and then from this particular sorted array, we will take the first and second element. So sum of sorted. Both of these are functions. So sum of sorted of array I to j plus 1. And within sorted, we'll have to take only the first 2 elements. So till 2. That's what we need, right? So hope that is understandable. Again, just to give you an understanding quickly. So let's say if I'm taking 4 and 3 as my array, right? So if that is the case, then I would, and let's say 4, 3, 1. So my sorted array would be 1, 3, 4. If that is the case, my summation would be basically 1 plus 3 and not 4 plus 3. That's what we are doing. We are taking first array of I till j plus 1. And then we are taking the first 2, we are sorting that particular array, taking the first 2 elements and then taking the sum of that. Either whichever is highest, we will replace count sum with that particular value. Okay, so hope that's understandable. Now let's move on. And at the end, I think we will just return count sum. So let's run this. Yep, expected output has come. And if I submit, okay, around 1,000 test cases passed, but around 100 test cases didn't pass, which makes sense given that this particular piece of code is taking a time complexity of O of n cube log n. Why? Because the first one is n, second loop is also taking n, which is n squared. And on top of that, we are using sorted function, which takes n log n time complexity of its own. So n into n log n, which is giving us the total complexity of n cube log n. So definitely this is not intended. We should optimize, if not for n, at least for n square. So let's try to optimize this for n square at least. So, okay, let's not take this out. So for n square, what will I do? I will take both of these loops in the exact same manner I was taking this. Okay, so we will keep this as it is, I in range of length of r, and for j in the range of I plus 1 to length of r. Okay, and then what will we do? We will probably just comment this one out. Okay, so count sum is max of either count sum or sum of that sorted array. Now what will we do? We will take two minimum possible elements. Okay, so let's take min1 and min2. Min1 being the smallest, min2 being second smallest, and both I would be initiating to float of infinity. That means these are taking the highest, like positive infinity value. And then if, let's take r of j is less than min1, then min1 less than min1. Min1 is the smallest, right? Okay. So that means if r of j is less than min1, that means we have found the least possible element, right? So we will first update, let's say min2 with min1, and then we will update min1 equals to r of j. Or let's say if r of j less than min2, then we will just update min2 equals to r of j. So what did I do here? Basically, I have taken two minimum variables, one for smallest, one for second smallest, and let's say what if I'm getting one particular element which is less than the smallest element? That means it's definitely less than the second smallest element, right? So min2 will be up. So my current smallest element which was there in min1 will become the second smallest. So min2 will become min1 and min1 will become rj, right? That makes sense. And then min2 is r of j. Now we will check if, let's say, either of the two elements, if those are not two elements needs to be there. So check if two elements are there. So if, let's say, min1 not equals to float of infinity or min2 not equals to float of infinity, then okay, these two are done. Then we will take count sum equals to max of count sum, comma, min1 plus min2. Perfect. Right, then we will return count sum. And that's it. So what are we doing in each of the array that we are taking? We are recalculating within the particular subarray. We are recalculating smallest and second smallest element. And once we get that, we are replacing that. And then count sum is getting replaced by its current value compared to the new value of min1 plus min2, whichever is highest. Yes, exactly. We want the highest sum, right? Yep. Okay. So let's compile and run. I think the logic is spot on, but let's see. Okay, runtime error main max sum a float infinity. Oh, okay, sorry. Yep. My output is infinity. Okay. Okay, let's see. So if r of j less than min of 1, 4 is less than min of 1, yes. So min 2 equals to still infinity and min 1 is 4. Elif r of j less than min 2. So elif में नहीं घुस रहा है. We are going to, if min 1 not equals to float of infinity, nope, either of the two, and not or, and okay. Okay, same thing. Okay, so we are able to pass almost 1,000 test cases, almost about 90% of the test cases are passed, but 10% is still left. So what I'll do, I think this particular problem can be solved using monotonic stack methodology, which is nothing but strictly increasing or decreasing order of stack values. So I will include the solution in the comments below. Also, let me know if you guys can find out any other solution to this particular problem. I'm not solving this at the moment. Let me know in the comments if you want me to. I can solve it later on. Okay, so for now, this is, I think, good enough. We are able to solve this kind of medium complex problems in O of n square. So now let's move on to the next question. Okay, so stock, buy and sell. Best time to buy and sell stock. You're given an array prices where prices I is the price of a given stock on ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in future to sell that stock. Return the maximum profit you can achieve from this transaction. Okay, so I think, okay, so I think I've got an idea of how to solve this. Let's just write the array down. 7, 1, 5, 3, 5, 3, 6, 4. Okay, so that is the case here. Now, let's say we will take two variables separately. What? One being min price, where we will basically buy and then we will max the profit. Okay, so what is the max profit? Max profit is maximum of the sell price minus minimum of min price, basically, right? That's what we need. So what are we doing here? Let's say while traversing through the loop, we will say if the current day price is less than minimum price, let's take minimum price to be, let's say, infinity. And then if current price is less than that, which it will be, then min price will be automatically updated by the current element. And then if min price is getting updated, that means our profit, we won't be selling it that day, right? Because it's minimum. Of course, we won't be selling it. So in the else condition, we will say that if min price is not getting updated, that means it is definitely higher than min price. The element is definitely higher than min price. If that is the case, then what's the profit there? So let's say at the second step or second element, 7 will again get replaced by 1. And then after that, at the third element, 5 cannot replace 1 because 5 is greater than 1. So at the else condition, we will check if the profit is the max of profit, basically. We will check max of either profit or the current price. Current price is something, let's say R of K minus the min price. Whichever is max, we will take that one. So we will take that, right? So hope that's understandable. This is very simple. Let me just code and I think you will understand. So let's say for I in range length of prices, right? Let's take two variable. Min price equals to, let's say, float of infinity. And we can take max profit equals to 0. If there's no profit, we can return 0. So yeah, of course, that's the default value that we can give to max profit. Automatically, we will return max profit, right? At the end of the program. Okay, so then for I in range length of prices, if min price less than prices of I, then min price equals to prices of I. That's it. It's just getting replaced. Else, we are trying to find out the max profit, which is nothing but the max of max profit, comma, the current element, which is arrow of, prices I minus min price. So that's what's happening. So let me just run through the array. So let's say if it's 7 is definitely lesser than infinity. So min price is getting replaced by 7, and then else condition is not running. Again, going back, 1 is lesser than 7. Again, min price is getting replaced by 1. 5, now 5 is greater than 1. So max profit would be 0, 5 minus 1, because price is I right now is 5 and min price is 1. So that's 4. Max profit is updated by 4 because 4 is greater than 0. Now next 3. 3 is again greater than prices of I. 3 is again greater than min price. So this won't be updated. So else max profit would be 4, 3 minus 1, 2. So it will stay 4. Again 6 will come. It won't get replaced. So 6 minus 1, 4, 5. Then it will be replaced by 5. Max profit will become 5. Again 4 will come, and if condition won't run, else will run, and 4 minus 1, 3. But max profit will still stay at 5, right? And then we were returning max of profit. So that makes sense. We are optimizing for minimum price and maximum profit. Okay, let's see what's the issue here. Output is 0. Okay. Why? Prices of I minus min price. Okay. Okay, let's debug quickly. If min price less than prices of I, min price greater than prices of I. Sorry, my bad. Yep. Cool. Okay, so this is good enough. Let's just move to the next problem. Rearrange array elements by sign. Okay, you are given a 0 indexed integer array nums of even length consisting of an equal number of positive and negative integers. Okay, you should return the array of nums such that the array follows the given conditions. Every consecutive pair of integers have opposite signs. Okay, for all integers with the same sign, the order in which they were presented in nums is preserved. For all integers with the same sign, the order in which they were present in nums is preserved. Okay, got it. The rearranged array begins with positive integer. Okay, got it. I think I got the problem. Return the modified array after rearranging the elements to satisfy the aforementioned conditions. So 3, 1, minus 2, minus 5, 2, minus 4. So the way it will be 3, minus 2, 1, minus 5, 2, minus 4. Yes, correct. That's the output. Okay, so how do we do this? Okay, so let's say for this particular problem, the idea that I'm having is, since I do not have to do this in limited space, I can take up extra spaces, right? And I'm thinking of taking another type of data structure, which is queue. So let's just take the array here, 3, 1, minus 2, minus 5, 2, minus 4. Okay, minus 5, 2, minus 4. This is the array that we have. Now let's say if it is positive, let's create a positive queue, and if it is negative, let's create a negative queue. Okay, so my positive queue will look like 3, 1, 2, and negative queue will be minus 2, minus 5, minus 4. Right, so these are the two arrays that will happen. Now what will I do? I'll create a third list, and first I will append from here 3, then I will pop from here. Again, I will pop from here. Again, I will pop from here. Okay. So that way, my one after another alternate positioning array is ready, and that will be my final output. Okay, let's do that. First, what we'll have to do, from collections import deck. So this is a different module that you'll have to import for queue. This is the most efficient one. Now let's take pause equals to deck. I'm just initiating a particular queue which is known as pause and negative. And let's say if I'm taking list equals to a particular array, then for I in range of length of nums, if nums of I less than 0, then neg.append nums of I, right? Else. And you should have, you are given 0 indexed, yes. Do I have 0? No. 2 to the power 2 to the power 2 into 10 to the power 5. Nums length is even. Nums of I is 1 through 10 to the power 5. Equal number of positive and negative integers, and I think this is not 0. There's no 0 here, so we can certainly say else. And this will be pause dot append nums of I, right? Now I can run another loop for I in range, same thing, length of nums. So L dot append, if I mod 2 equals to 0, which is at the starting, then L dot append pause dot left pop, else L dot append neg dot left pop, and then return L. I think that's what we need to do. L. So we're taking a lot of time, a lot of spaces here, 3 extra spaces. Left pop. Okay, let me just check. Oh, sorry. This is not left pop. This is pop left. Pop left. Let's run. Cool. Let's submit. I think this is an easy one, but okay. Since probably we're taking extra space, it's not preferring this particular solution a lot. We can do different kinds of solutions for this as well, but I think this is getting solved in O of n itself. So this is a good enough solution. Let me know in the comments below if you would like to solve this in a different methodology, and I'd love to learn from that as well. Okay, all right. So that was it for today, and we will solve the last part of the medium array problems in the next video. So stay tuned and happy learning.